Hi everyone, we are going to go over section 2.4, solving equations with variables on both sides. So we've done 1 and 2 step equations, multi-step equations, and now we're going to do equations where the same variable is on two different sides of the equation, okay? So I need you guys to take notes. As always, write down questions that you have, and I will be sure to go over them in class. So we do use those same properties of equality and those inverse operations to solve equations with variables on both sides of the equations. Okay, so it's really important to know that we can also do it when we have both sides of the equations. So our first example, we want to find the solution of 5x plus 2, which equals 2x plus 14. So when it's asking us to find the solution, what that means is that we need to find our variable. We need to know what x is to satisfy this equation. So the way that we do that is we want to combine all of our like terms. We want to get our x's on the same side of the equation, and then we're going to solve like normal. So as I can see, I have a 5x on the left and I have a 2x on the right. Now, you can either move the 5x or the 2x. I like to move the smaller number because I think it's easier to deal with, and then we're staying in positive numbers. But you could try this on your own moving that 5x, and you would get the same answer. So if I want to move this 2x to the left-hand side of the equation, I need to do the inverse operation to get it to the other side. So I see nothing in front, which means that I have a positive 2x, which means in order to move it to the other side, I need to get rid of it by doing the inverse operation of subtraction. They cancel. Now I've already done it on the left. I already did it on the right. Now I have to do it on the left. So I'm going to subtract 2x. Now I only do it from the 5x because I can't subtract it from the 2 because they're unlike terms. So I'm going to bring it down, coming over here. 5x minus 2x gives me 3x because I just deal with the coefficients, and then nothing else changed on the left-hand side. So I have 3x plus 2 equals, now this 2x is gone and I'm left with a positive 14. Okay? Now, in order to get this x alone, I need to eventually move the 3 and then the 2. Now, the 2 is further away from the x, so I'm going to use that one first, and I'm going to get rid of it by subtraction. On both sides, I'm left with 3x equals 14 minus 2, which is 12. Now, how do I get this 3 away? Well, they are linked through multiplication, so I want to do the inverse operation of division. That gives me a 1, 3 divided by 3, and I'm left with 1x, which equals 12 divided by 3, which is 4. Okay, we are going to check this over here. So anywhere I see an x in my original equation, I'm plugging in that 4. So I have 5 times 4 plus 2, and I want to see if that equals 2 times 4 plus 14. Okay? So if I start from the left, 5 times 4 gives me 20, plus 2 equals 2 times 4, which is 8, plus 14. Okay? Left-hand side, 20 plus 2 gives me 22. And then 8 plus 14 also gives me 22. So I'm good. Okay? Now I want you guys to try one on your own. You're going to try this problem. 7k plus 2 equals 4k minus 10. All right? So you guys try this one on your own. I'm going to move on. So our next problem, I see parentheses, okay? So we want to find the solution again. I see x's on both sides, and we want to get those x's on the same side and then eventually solve. So first thing I need to do, I see parentheses. So what I need to do is distribute whatever's on the outside of those parentheses to the inside, okay? So I'm going to have 2 times 5x, which gives me 10x, minus 2 times 1, which is 2, equals 3 times x, which is 3x, plus 3 times 11, which is 33. Now I look like I have a problem I did in example 1, where I have 4 terms, an x on the left and an x on the right. So again, you can move either term you want. I'm going to move the 3x because it's smaller. So my 3x is positive, so I want to subtract it from both sides to get rid of it. So my left-hand side becomes 10x minus 3x. I'm left with 7x minus 2 equals, this goes away, and I'm left with 33. Okay? So I have a 7x and a 2. My 2 is furthest away, so I'm going to deal with that first. I see a negative, so I need to add to get rid of it. Inverse operation. Add 2 on both sides. I bring down my 7x, and that equals 35. 7 times x, so I want to do the inverse operation, which is division. Divide by 7, and I'm left with x equaling 5. Okay? Let's check. Actually, you guys check this on your own. So I need you guys to check. And then I also want you to complete a very similar problem. I'm going to do this one in yellow. We're going to do 4 times 2y plus 1, and that's going to equal 2 times y minus 13. Okay? Follow the same steps. Distribute your 4 first, distribute your 2 second, and then you can go from there. Let us get rid of this, and we will do the next. Okay, so I have 2 definitions for you, and then we just have 2 more problems, and that's it. So when we've been solving all of these problems, we've always gotten an answer. We've gotten x, or whatever our variable is, and we've gotten one number to solve our answer. So there's 2 other situations that could occur. The first situation is called an identity. Now, if that occurs, what that means, sorry, let me just make sure I can, okay. If an identity does occur, what that means is that every single number that ever exists, so infinitely many possibilities, could satisfy that equation. So I'm going to show you an example. Let's say my equation is this: x plus 1 equals x plus 1. Every single number you put in for x, you're going to get the same thing on the other side. So if I put in a 3 for x, I get 3 plus 1 equals 3 plus 1, which means 4 equals 4. Which means that any single thing I plug in, I'm going to get the same thing on both sides. If I plug in 100 for x, I get 100 plus 1, which is 101, equals 100 plus 1, which is 101. Meaning that there are infinitely many solutions that satisfy this equation, where it's still true no matter what. Okay? Now, if we bring it down here to no solution, that means that there is not one x or one variable that will satisfy that equation. Nothing you plug in will ever work. And this is an example of that. X plus 1 equals x plus 2. If I plug in 3 again, I get 3 plus 1 equals 3 plus 2. That's not true, is it? Because 3 plus 1 is 4, and 3 plus 2 is 5. And that is not true. 4 does not equal 5. Nothing will work. Anything you plug in for x will not work. So there's no solution that makes that equation true. Okay? So we are going to put this into play, and we're going to see what we get. Okay. So I just have 2 equations left, and then we are done. So we're going to do the first one in orange. So it wants us to know what's the solution of each equation. So if I'm looking at this one on the left, I have 10x plus 12 equals 2 times 5x plus 6. Looks like a problem I had before. I see parentheses, so I need to distribute this too. And the goal again is to get x alone. So my left-hand side, I'm not doing anything to, so I'm just going to rewrite it. I have 10x equals 12 plus 12 equals 2 times 5x. That gives me 10x. Plus 2 times 6, which is 12. Now stop right here. If I look at the left-hand side and then I look at the right-hand side, I see the same exact thing. If I see the same exact thing, this means that it's an identity, okay? So this is an identity. If you remember back to the formula, or the definition that we went over on the last page, an identity means that there's not just one solution, there are infinitely, that's the sign for infinite, infinitely many solutions. You couldn't even list them out. There's too many. It would never end. Okay? Let's bring it over to the right, and let's see what we get. So I see 5 terms. My left-hand side is 9m minus 4, and my right-hand side is negative 3m plus 5 equals 12m. We know from the last section that I can combine these two terms because they're both m, they're like terms. So if I combine these two, I get negative 3m plus 12m. That is going to give me 9m. So let's take a look at what we have here. I have 9m minus 4 equals 9m plus 5. When these two are the same, you know something's up. Either it's an identity or it's no solution. If it's an identity, then these extra numbers added or subtracted on must be the same, and they are not. So nothing I plug in for m will ever make this statement true. So the answer to this is that there aren't any. No solution. Okay? Please write down questions. I really appreciate you guys sticking through these videos. It's really very important.